This is LeverA Answers, answer submission. Picture of the resistance force. And this is the force of the load. 25.28 is the same number we're going to use for all of the labs. This is actually just a picture of the lever that we were doing. You have your fulcrum down here at the end, your resistant load right here hanging from the lever, and then effort down on this end here with a scale measuring actually how many pounds of force it takes to hold up this load that's 25.28 pounds. Okay, so you've got a picture of actually this is your force, 9.02 pounds of force used by that lever to hold up the 25.28. So that is the correct answer. What is the effort force on the lever? 9.02. And number two, the load force is the force output by a simple machine. The load force is the job the simple machine is doing. Oftentimes the load force is the weight that's being lifted. So in this case, your weight that's being lifted, sometimes you call it the load, sometimes you call it the resistance. It means the same thing, but in this case it's 25.28. Okay, and that's just the number that we saw on the scale. AMA is the force of your load divided by your force of your effort. So for this one here, you're doing 25.28, which was your load force. This answer right here, 25.28 divided by your effort, 9.02. And if you divide those, you get an answer of 2.802. That's your actual mechanical advantage. Question number 4, distances were measured with a tape measure attached to one end. Remember, this is your fulcrum, that piece of metal that's right there, and it's hooked over the tape measure is hooked over the end of the tape measure. So the fulcrum is 6 inches. That's your answer for number 4, 6 inches from the end of the board. Okay, here's your distance. You can see the tape measure is hooked up here to the load is 24 inches from the end of the board. So that's your answer for number 5. Number 6, the load distance is the distance between the load and the fulcrum. So you have to subtract the 6 inches, these 6 inches here, from the 24 inches to get the distance between the fulcrum and the resistance. So 24 subtract 6 gives you 18 for question number 6. Question number 7, the effort force lifted the end of the board. Here's the effort lifting right here. And how far was the effort force from the end of the board? 95 inches. And I'm just looking at the tape measure here where the rope is wrapped around the end of the lever. That's for number 7. Number 8, the effort distance is the distance between the effort force and the fulcrum. So again, we have to subtract the 6 inches from the end of the board to the fulcrum. 6 inches, subtract that from the 95 inches. So we get 95 minus 6 is 89. Question number 9 is just asking us to calculate the IMA. IMA is your effort distance divided by your load distance. The distance from the fulcrum to the effort, we just calculated it. It's 89. The distance from the fulcrum to the load is, what was it, 18? Yeah, 18. So we divide 89 is your effort distance, divide by 18, your load distance. 89 divided by 18 is 4.944. Make sure you answer like it says. Always pay attention to how many decimal places or how many places to the right of the decimal point you need to have your answer. In this one it says 3 places. So that is rounded to 3 places to the right of the decimal point. And then question number 10 just asks us to calculate the efficiency. Efficiency equals AMA divided by IMA. We just calculated the IMA, and the AMA we calculated way back up here in question number 3, I think it was. There it is right here, AMA. And we found it's 2.802. So AMA 2.802 divided by IMA 4.944. So 2.802 divided by 4.944, and then you're going to multiply that by 100 to turn it to a percent. And when we do that, we get 56.675 is the answer, 675. But it says to 1 decimal point, so we need to only be one number to the right of the decimal point. So it needs to be 56 point something. If you're rounding to the number to the right of the decimal point, to one digit to the right of the decimal point, you're going to use your second digit to round off your first digit. If the second digit is 5 or greater, you're going to round the previous digit up. So in this case, it's 56.675. The 7 is greater than 5, so we're going to round this, instead of at 56.6, we're going to round it to 56.7. And that will be that. So you guys, these are your correct answers. You can use your answers to make corrections on your answer submissions. You should get them all right. Make sure you know how to do them for the test, though. Okay? Email me, get in a Google Meet, ask questions if you have any.